Good evening, everyone. I am back with webinar number 34 with Ashish Shah ji. And I feel that we must promote and use new technology available. And today we are going to talk on a very new topic, very relevant topic of optical CTs and VTs for generation, transmission, and distribution network. Dear all, it is known to everyone that CT, PT, VTs are very important and critical component of any network, be it generation, transmission, distribution, any industry, solar PV system, hospitals, any other RE network. When we say CT and VT, they are used mainly for metering purpose, protection purpose, and presently both are governed by IC 61869. CT and VT have many cores and ratings depends on the voltage systems and the requirements. All these cores are connected to control and relay panels in the control room through control cables of different size. In the present era, with the advancement of technology, everything has become smart, codeless, cableless. And every time we talk about substation automation systems, digital substation, in both cases, the optical CT and PT will play a vital role. And to understand the same concept, I have arranged today's webinar with respected Ashish Shah ji. Before I invite him and give introduction, I would like to give thanks to the persons who are working for this webinar to happen, who are supporting me every time, includes Almighty, my family, my parents, my wife, my son. My mentors include respected PP Bhai Saab, Anjuli Chandra ma'am, Dr. Kamal Bansal sir, K. Murthy साहब, N.K. Mittal साहब, P. Ramachandran sir, S. Pau sir, Hitesh Chauhan ji, Arvind Thukral ji, Sanjay Agarwal ji. My friends and well-wishers include Saket Gupta ji, Umesh Gupta ji, Dr. Vikas, Amandeep ji, Pradeep Garg ji. Last but not the least, my team working 24 into 7 to make this webinar to happen includes Gulab and Ramdhani. Now, time to give a brief introduction about today's presenter, Ashish Shah ji. He is a owner of Green Bean Energy, which established in July 2023 and who is a authorized dealer of Profotech JSC Moscow, Russia, who are manufacturing optical instrument transformer up to 765 kV for AC and DC applications. They are also manufacturing RIP and RIS bushings up to 550 kV. Mr. Shah has experience of more than 22 years in the electrical field, and he has also worked with Tibia as a head project execution engineer, PTW, and Talta. He has also worked with transformers and rectifiers and also worked as a consultant for FIDA Environmental Science and Technology for flue gases desulfurization projects. Time to hand over to Ashish Shahji to rock the platform with the knowledge he has. Welcome, sir. Welcome to the show. Kindly start your presentation.
So presentation is visible? Hello? Hello?
It is visible. Continue.
Okay, okay. So good evening all, sir. Good evening all members. Uh, as sir said, this company belongs to Russia. Name is Profotech. So I'll start with the brief introduction of this company. Profotech established in December 2010. It is a group company of Russian Nano, JC headquarter in production line in Moscow, Russia. And product they are manufacturing fiber optic instrument current transformer based on Faraday's effect and electronic voltage transfer and combined transfer. Purpose high precision measurement according to IEC 61850-9-2 for digital substation equipment. Purpose commercial metering, relay protection, automation, etc. Application area transmission and distribution network, generation, power consuming industries, reference and laboratory measurement. Here, here is a comparison. Before that, we just give the idea about the working principle of this optical CT. So here, current passes through the conductor, and the light fades to the optical winding, and the phase shift occur that will be determined as a current measured. So in case optical properties of the fiber is changing and the speed of propagation of the light wave along the circuit becomes a different between the waves at the exit from the circuit, a relative phase shift occurred. This phase shift occurred is considered as a current measured. So here mechanical difference is if you see the mechanical electromagnetic current transformer, it is filled with the SF6 or oil. The transformer weight is around 900 kg, and it uses the core and copper for the manufacturing and oil. But in case of optical current transformer, the transformer weight is only less than or equal to 390 kg, and there is no any oil, there is no any copper, there is no any core. Core material are used for this manufacturing of this optical current transformer. Apart from this, it is there is no any fire hazard or explosion possibilities there in this. In compared to city, there is a chances of fire and explosion hazard is there. Another advantage is absence of electromagnetic saturation effect. If you see the conventional transformer core consists of electric steel core, copper winding. As a result, conductive element in case of short circuit loss metering properties. From this conventional CT, optical transformer core is made from the consist of only spun fiberglass, and there is no conductivity element and nothing to be saturated. Advantage in size and weight wise. If you see the conventional CT, it is 450 kg compared to, if it is a 450 kg compared in comparison optical CT only 70 kg. So if you see the weight wise is lighter than 85% and smaller in 24%. Insulation material. In conventional SFC is gas used and oil are used. In optical CT use only some environment friendly insulation gel using between this post insulator. Here they have one solution which is providing combined solution of optical CT and PT. So if you in substation voltage transformer and current transformer are separately installed, but in case in this CVT, there is no separately installation required. There is a combined unit that is called as CVT. We can measure both current and voltage in combined module. So your copper cables, you can remove the copper cables and laying and other things, and you will just need only one single fiber optic cable can be used to measure the current and voltage. So cost economy wise, you will get the more advantage because there is no number of cable you can remove. Your space is also, you can save your space because of single module available which can measure both current and voltage transformer. Metering and protection for digital substation as per the IEC 61850. This is here picture shows the conventional substation. wherein you have to lay number of cables, and also the panels are more in comparison to the digital substation. So here the 6 panel in comparison only 3 panels, and number of cables you can remove. Single fiber optic. Here is the uh, NCIT, which can measure the voltage and current and fed to the optical closer, and from optical closer it is fed to the this EPU unit, electronic processing unit, and from electronic processing unit you can take the input to the relay metering device, any other instruments. So the benefit is you can reduce reduction in capital good capex and reduction in operation cost. There is a comparison between conventional substation and digital substation. Here is the number of cables we are laying to feed the control room. Here only one single fiber optic cable we are connecting to the control room. We have this is the production line, and we have around 5 type of instruments which we are manufacturing. One is this CT, optical current transformer. Another is optical current transformer flexible type CT. Another is a reference CT, which can be which you can which can be transported to anywhere for measurement of harmonics and current, for current measurement, current component. Another is a voltage transformer, electronic voltage transformer, and this one is a combined unit of electronic voltage transformer and current optical current transformers. Now come to this fiber optic current transformer, EFOCT. The construction is in this is aluminum casing. In this casing, we are using the two fiber optic spun fibers, two spun fibers. One is used to measure the temperature, and one used to measure the current. So this spun fiber cable is connected to this optical closer, and from optical closer it will fed to this EPU unit. The parameters we measure from 0 to 750, 765 kV volt, and from 300 to 190 kiloamps. For measurement accuracy class, for measurement 0.1 to 1, 0.1, 0.2, 0.2s, 0.5, 0.25s, 1, and protection class pi TP and SE. Sensing element temperature range is -60 to +60, and rated short time thermal current 31.5 kiloampere. The rated dynamic current NE frequency from 2500 kilohertz. Distance between sensing element to electronic processing unit, no distance limit. It means from this unit to control room, you can lay cable to any distance. There is no any restriction up to this distance. You can you can lay the cable. You can lay the cable to up to any length. Power consumption 150 watt. Digital output, digital standard. Output specification is IEC 61850-9-2, SV80 and SV256. Sample rate according to IEC 61850-9-2. Sorry, sample rate is SV80 and SV256. And digital standard is IEC 61850-9-2, IEC 61850-818-1. Sample rate is SV80 and SV256. time synchronization IEEE 11588-2008. Redundancy PRP. The dimension is for 110 kV 650 by 355-355 into 1900. For 220 kV 660 by 500 by 3000. 500 kV 1440 by 1440 by 5570. And weight is for 110 kV 70 kg, 220 kV 110 kg, and 500 kV 400 kg. So these are the weight and dimension parameters. Of EFOCT. The EFOCT for bus. So this one is useful for the processing industry, like aluminium furnace, chemical industry, where they are using a rectifier transformer and a furnace duty transformers, where high current are delivered to the equipment. Then EFOCT for GIS. This one is for GIS, where this is a flexible city which can be installed on the GIS. This is a EFOCT for that tank DCB. Here is the looping for flexible city. On a transformer also can be installed. This can be installed on a bushing outside the bushing. Then overhead line. Then generator protection on a cable or bus bar. No, we can install this flexible city. Another one is a pedestal type up to with a 5 kV pedestal, and another is 20 kV pedestal. Then integrated into the live tank DCB up to 500 kV, and suspension type 145 kV and 500 kV. This is this one. This one is EFOCT 145 kV, EFOCT 245 kV, and EFOCT 500 kV. Here is the flexible CT, which is installed on a bus bar. So these are the output: frequency output, milliampere output, fast output, and IC 61850-9-2 output. So here is shown the EPU unit, which is a one type of processing unit. From that you will get the output, desirable outputs. The sensing element can measure from up to 350 kiloampere and up to 600 kiloampere by request. Accuracy class 0.2, 0.1, 0.005. This is a voltage transformer with capacitive divider. This one is from optical closer to the electronic processing unit. This voltage transformer can measure from 110 kV to up to 765 kV. Measurement accuracy is 0.1, 0.2, 0.05, 1, and 3. For protection class 3P and 6P. The sensing element can perform from -60 to +60. An EPU unit can measure frequency. EPU unit processing from +5 to +40. Rated frequency 50 or 60 Hz. Expanded frequency band from 20 Hz to 5000 Hz. Distance, there is no limit for laying the optical cable. Digital standard IC 61850-9-2 SV80 SV256, IC 61850-9-2, IC 61850-8-1. Sample rate SV80 SV256. And these are the dimensions. This is a combined module of CT and PT. So here is a sensing element for current measurement, and this is a capacitive divider, and here is a ADC converter. The output of this sensing element and ADC converter goes to the optical closer, and from optical closer it will fed to the EP unit. There is a two EP unit. One is for the current transformer and one is for the voltage transformer. The height of this means you can this EP unit can be installed in simple 19-inch rack, so it uses a very less space in control room as well. So this current voltage transfer can measure from 110 to 765 kV, rated current from 100 to 3000 3000 ampere, and mechanical terminal load from 200 2000 by 3000 2000 and 3000. Voltage for measurement 0.1, 0.2, 0.5, 1 and 3 accuracy class. Voltage for protection 3P, 6P. Current for measurement 0.1, 0.2, 0.2S, 0.5, 0.5S, 1. Current for protection 5 TP and SE. So this is the same parameter and can measure from 20 Hertz to 5000 Hertz. Cable can be laid from any distance, and digital standard is the same IC 61850-9-2. The dimension here is 110 kV, 650 by 400 by 2100. 220 kV, 700 by 800 by 3100. 330 kV, 1050 by 1050 by 3600. And weight is 110 kV, very less weight if you compare the separate module of separate unit of voltage transformer and current transformer. The total weight would be higher. In comparison, only 127 kg, 220 kV, 180 kg, 180 kg, and 330 volt, 330 kV, 222 kg. The custody transfer spot for energy consumption industries. The combined CVT for 132 kV, 220 kV, 330, 500, 765 kV. So here they have just given some layout. This is a combined module of this CVT, and it is installed in a control room. So from control room you can connect to the Ethernet switch, and also you can connect to the this energy meters. The economical effect on average for a year for connection of 220 kV class, the saving due to an increase in accuracy class can be up to 20,000 to 57,000 US dollar. So we can save much amount in comparison to the conventional CTR. The traditional transformer and meter, the complex error is up to 2.5% when using CT with 0.2S, PT 0.2 and counter 0.2S. For optical CT, the optical CT and digital VT with the digital counter, the error is 0.4%. So here is 2.5% and comparison only 0.4%. Just for the aluminum or furnace industry, where these flexible CTs are used. This is a flexible CT mounted on this bus bar, and this is a whole coil, whole effect coil, and they have installed this flexible CT. This device is used for calibration and precise metering for laboratory. The Profotech optical current are widely used in laboratory for precise metering due to the test conducting. The accuracy metering class 0.05, compact and transportable design, easy mounting make it widely used amongst local and world-known testing centers. EFOCT, EFOCTF, EFOCTF reference are certified instrument and included in registry of Russian and Kazakhstan State Agency of Measurement devices tested in Russia and international high voltage laboratories. These are the some of the key reference lists: Mitsubishi Electric, Rostom, DNV Holland, Turner Italy, FSUE, and High Voltage Research Center US. The major benefit: uniquely high measurement accuracy and ability to measure harmonic component up to 50th order. If you see the conventional CT, it's been difficult to measure harmonic component up to 50th order. But in this case, you can measure up to 50th order. Easy and flexible system scaling, automated workplace that allows you to track the result immediately in the test process. Wide temperature range of the sensing element, significantly smaller weight and size parameter, ease of installation and operation, does not depend on external interaction. Large magnetic field, dustiness, gas pollution. Doesn't require precise position related to the conductor. Simplicity of installation does not demand rapture of the bus bar. Convenient and easy to transport. Can contain from 1 to 3 phase. And flexible developments. So here in Russia, then Finland, Switzerland, then in US also. The key projects are this is a KEMA project where 220 kV flexible CT was installed. This is a wall mounting bushing, and this is the CT flexible CT. Here also they install this. And in Switzerland, they also this NCIT with a combined module of 145 kV. In Finland, they install 110 kV combined module. This is a DC in Kazakhstan. DC is a flexible coil. Then EFCT in Finland. EFCOT FAC, high voltage test center in USA. Then in CSI Italy. Then Swiss grid. This is hydropower plant. Hydropower plant where this cable is passing through this line, and this is a flexible CT installed on this cable. The Rus Hydro, Russian hydropower plant. This is a flexible CT. The Russian grid where they in 500 kV substation this CT was installed. And voltage transformer. This optical current transformer, and this is a voltage transformer. This is an aluminum plant where they install this flexible CT. And in Canada, they install 765 kV EFOCTF, means optical CT. These are some close view of this installed flexible CTs. Hydropower plant, then this generating power plant. This is the APU unit installed in a substation. Installed in GIS. This is flexible CT. Photo of KEMA. Aluminium plant where this flexible CT installed. This is a photo of Fin grid where they have installed this optical CT. This is the conventional CT in line with this, they will install this optical CT. Is 500 kV optical CT and 500 kV voltage transformer. And 765 kV CT installed Canada, Quebec generation Canada. And this is a reference optical transformer, and this is a transportable device, and where this can be carried anywhere to measure the harmonic and current components. Finish, sir.
Okay, and thank you very much, Ashish ji, for your presentation. Now I have very small question on behalf of all the participants because I was expecting some presentation on the fundamental side, but that was not on fundamental side, that was on the information side. I have some queries. The very first query that start is, you have mentioned that that is applicable for AC as well as for the DC application. Can
Yes,
you
sir.
throw some light how it is applicable for those both? Number one. Question number one. Kindly reply that one. That is.
It
How
is
the
for DC application mainly. This just I will open that slide.
Please, please. Because I have 10 small questions that should be answered to make all the participants clear about that technology. Then I will ask question from participant also. And
Can you repeat the question? Can you repeat question? Just a minute.
how do you differentiate between the principle of measurement in AC and DC? Same, how the same instrument can be used for both application? Kindly elaborate that thing. Suppose there is one,
For AC,
yeah, AC is flowing and DC is flowing, same instrument. How will you use the same instrument for both application?
okay. So my presentation visible or not, sir?
Presently not.
Okay. I will share the presentation.
Please, I and all participants would love to understand the fundamentals. Your presentation is not with you. Yes, now
Yeah.
it's yes.
So here, if you see this
Yeah.
EFOCT, fiber optic current transfer for AC and DC application. So
Yes, that's why
this CT can measure both AC and DC. Similar way, this reference CT, this one also measure both things. This one can also measure AC and DC.
I
Thing is that
understand. I have understood the product, but I just want to understand the fundamental principle, how it can measure both AC as well as DC. Just
so thing is that when this here sensing element is common for both. Okay, sir. There is no any change in sensing element design. Only the design will change respect to the current rating and voltage class. So design is changed, means number of winding they change according to their voltage and current requirement. This this can be changed according to the voltage and current requirement. Nothing would be changed. The thing is that in electronic processing unit, they are making some changes because this product is belongs to Profotech. They know better in better way. The design principle means how they are doing the programming and other things. What are the kind of chips they are using in to make differentiate between the.
and tell me one thing. You mentioned that there is no saturation. That means any city can be used as a metering and protection city. Then how do you differentiate the two things? Because the protection class cities are different, meeting class cities are different. how the same city can be used as both metering as well as protection.
In conventional city, na, we
Yeah.
are designing the core according to the protection and metering class. Okay, sir. But
Yes.
here, in this case, this sensing element measure the current, because current is it current current means current passes to the conductor. If DC is there, and if it is a AC, then it is as per the sine wave, it is passing to a conductor. So the sensing element measure the current and fed it to the EPU, electronic processing device. An EPU device will measure the light fluctuation. I mean, as I told, this is the phase deflection. This deflection will give the light, so give the phase shift, and accordingly phase shift occurred, that will be determined as a current measured. If it is a DC current, that will be a continuous current passing to the conductor. So accordingly, this light source will be light wave will be shifted.
No, my question is quite different. There's for metering city the requirements are different. For protection city the requirements are different. And how the same city can fulfill the requirements of metering as well as for protection city in the substation.
So here thing is that there is no core and copper. Okay, sir. This sensing element measure the current, and measured current is through the light source. So light source will be fed to the EP unit. So
Okay.
EP unit only is a device where you have to define for which measurement you want. Accordingly, they do the programming, and they will give us
Okay.
the entire unit.
Okay.
So main thing is
tell me how do you
yes, sir.
differentiate between the different metering class 0.1, 0.2, 0.5, 1? How do you
So
make
according, sir, the thing is that the class.
what I can understand is everything is done at EPU only. The basic
Yes,
principle of
it will be
measurement
done because this is a spun fiber only measure the current, and according to measured current, the light source will be fed to the EP unit. So based on light frequency, it will check. It will sense light frequency, and accordingly it will give the result.
Tell me one more thing. Suppose I have to go for procurement of that optical CT. There should be some IEC codes and type tested material and how to ensure that thing. Do you have any relevant IC code applicable for optical fiber? That optical CTP?
I that from here, that I know about this testing methodology and other things. But as per the uh, IC, that means the data streaming is according to IC 61850. But testing, that I had to check with the company how they are performing their test according to
Yes,
which IC standard.
because without having any material type tested, no one can purchase in at utility, in fact.
Yes, sir, I understand. But thing is that they have delivered many equipment to world across the world. So they are performing the test, even though they have supplied to the KEMA, they have supplied to the CSI laboratory. So according to without standard, they have not performed. So 100% they are performing the test according to the international standard.
Okay.
So I need to just check.
And what about the short circuit level? How to ensure the in our system the short circuit level has increased, that has gone up to 63 kiloampere. How to ensure that short
If
circuit capability of CTPT?
means this can measure 190 kilo ampere, so it can withstand the short circuit very well. the part from the short circuit, na, they have already done a short circuit test within us, Russia, and I'll show you the report.
Okay. Now I would like to invite participants to kindly raise your hand one by one, and you can ask your question, whatever comes in your mind, directly to Ashish Shah. Stop staring, sir, and I will invite question right now. Stop sharing.
Yes.
Yes, Anant, you want to ask something? Kindly unmute yourself. I request everyone to raise your hand one by one so that you can ask question directly to Ashish ji. Anant, kindly unmute.
Hello, good
Yeah,
evening, sir. Good evening, all.
good evening.
I posted 2 to 3 queries. As sir rightly indicated, without the standards being complied, the user may not be uh, complying and using that. So, any IS standards do we have? And second, is this technology in the verge of you know make in India? Because as I listened, it is made in out of India at this moment. So any such plans that this is to be made in India? Because all the users are now choosing made in India products uh, in the due course of time. Thank
Very,
you.
very valid question.
Sir, we are also planning to have a manufacturing unit in India, but at present, looking to our order booking, so we don't have only one customer presently we have, that is a Vedanta. In Vedanta Aluminum at Jharsuguda, we have installed one flexible optical CT that is used to measure the 400 kilo ampere current. But at present, we are trying for to get some orders, and based on order, we will plan to start our manufacturing unit in India. But we are now we don't have any means we need some orders, so at least we can we can think of starting of product manufacturing unit. We need some time. After some time, we will start.
Okay. Another question, Anandji.
Regarding the post-sale service uh, for this equipment, if this goes in saturation, demagnetization, uh, I think this being a new and wonderful technology, initially the users would also look out for post-sale support. So, do we have a team in India who actually would take care of this?
At present, sir, our company, Greenbean Energy, will provide the service support when during the installation time. During the installation time, company person will give us the training, and after sales and service, after training and installation, service part will be in our scope.
Great, sir. Thank you. I wish you all the best for the
Thank you. Thank you.
future. Thanks.
Any more question? Kindly raise your hand. I will unmute you and allow you to ask question directly. Any question coming to your minds can be asked. Kindly raise your hand. Icon is there. You have to just press raise hand. Sunil sir. Sir, welcome sir. Kindly unmute and ask your question. Welcome to the platform. If you can
Hello.
your camera, that will be good because that will become interactive.
Are you able to listen me?
Yes, yes. Kindly open your camera. We want to see you. That will become more interactive.
Sir, my two questions are, first thing is that whether there is any effect on this type of the cities of DC offset current present during the short circuit current. And second question is whether you have said that there is a capacitor divider is there provided for PT. So if there is any problem or if there is any variation in the capacitance of the capacitor divider, then whether the accuracy will affect or not.
Good question. Very good question, sir.
So, sir, first question, hello. First question regarding this short circuit. No? So here thing is here in this
Not short circuit, that was a DC offset effect. That is quite different from the short circuit.
DC, hello,
Offset.
DC offset. So here in this in this device, there is no DC effect would be there because the outer if you see this outer layer, I'll share this presentation just a minute. This outer layer is cased in aluminum, so there is some alloy material they are using, aluminum alloy material are using, which there is no any DC interference in this. So there would be no any effect. There would be no any effect. Hello.
Hello.
Yes, sir.
So here the thing is that this fiber optic cable wrapped in the aluminum case, no? So there would be no any interference of DC effect or anything. No? So and here also in flexible CT they use some composite material.
We are basically not asking about the DC interference. We are talking about DC offset. That is the component that is generated during the short circuit happens. Am I right, sir, Sunil, sir?
Yes, yes.
So I will check with my
Please.
production team.
No issue. Take your own time. Take your own time. It's a new technology. We can understand. All questions can't be answered at once. Any question? Kindly raise your hand. I'm waiting. Stop sharing, sir. Any other question from any participant? If they are feeling that they want to know the right time to get the answer. I think there are no questions left. Then I would like to invite Honorable Respected KK Murthy Saab to say vote of thanks and give his view first, then vote of thanks. Kindly unmute, sir, and open your camera. We want to see, we want to have your blessings.
Okay. हेलो, नमस्कार 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 अरोड़ा साहब। ये तो आपने बहुत अच्छा काम किया कि ये ऑप्टिकल सीटी के बारे में ये वेबिनार रखा। एंड आई कंग्रेचुलेट मिस्टर Ashish Shah as well, that he has been kind enough to accept this, though as Arora Saab has said that many questions cannot be answered here, and this is the preliminary webinar. I have been. I told Mr. If he remembers, I had told Mr. Ashish
Yes, sir.
because the Tech IT was being held at Mumbai, and
Mumbai, yes.
and he belongs to Baroda only. So I said, why don't you come and showcase your equipments? And as I see today, that he has got only the literature, not the equipment.
Yes, yes.
So he has to propagate his this thing, and meet all the electricity boards or all the utilities, and he has to develop such confidence that they accept it. And the basic thing is the most of the these utilities are concerned about the availability part, apart from the this price differential. Price differential must be very much.
And
See,
type test also.
yeah, yeah. And as you have clearly mentioned that the short circuit current of 63 kiloamperes, whereas it is showing that it is 31.5 only. Okay, the
Yeah.
short circuit current is 31.5, so that is not sufficient. And as things go, you have to be very confident about any equipment, because CTs and VTs are the life this lifeline for the power sector. So you have to be very confident, and any failure anywhere will cause a lot of disaster in power, particularly in the grid. So in the initial stages, you have to develop confidence in all the Indian utilities. And as he
Yes,
says, that his company will come here after the order. Any utility in India will not order like that, you see, unless they're quite sure that any equipment conforms to IEEE or IEC standard. So the Russian standard perhaps we are not aware of. And this is a Russian equipment. And as Mr. Sharde has said that what is the after sale service option. So that is of course very important. And and it has been a very, of course, enlightening, I would say. And first of all, I will say that the presentation was it was from it appeared like a, screenshots. It was not a this PPTs. So the whatever we wanted to know or see, it was so small we couldn't make out. So that is one thing you have to you have to prepare PPTs for such presentations.
okay, sir. That we will improve.
Yeah, then only will improve. See, you have to, when you present something, it should impress the others. Otherwise,
Yes, sir.
all said and done, it is a very good effort, and you have been able to come forward with a new technology and new product, and having so much of courage facing the whole this power sector people, power fraternity, by way of this webinar. And our great Aurora Saab will put it in YouTube also. So that way lot of publicity will be there. So with this, I wish you all the best, Mr. Ashish, and heartiest congratulations to Aurora Saab also, that as he was asking any question or any question, so anybody can ask any question. He is the person who can ask any questions to any presenter, which others wanted to ask or are hesitant to ask. He will ask each and every question. So you don't have to bother for that. So that's what I was also
Okay.
thinking. Hmm? It's a fact. It's a fact that he has got that talent. And I must appreciate Dr. Arora for that. And it's an opportunity given to me to speak before you. I feel really proud. Thank you so much.
Thank you, sir.
Thank you. Thank you.
Uh, Shahji, before we leave, another question that was not answered. You have mentioned many times in your slide ADC converter. Can you throw some light on that? What the role of that ADC in your instrument?
That also means ADC preliminary just I give the information. It is just convert the analog signal to digital signal, sir.
Okay,
Okay,
analog
and
to digital signal. Okay,
that is the only converter, sir.
okay,
And this voltage divider, no, it is divided by 57 volts.
okay,
And capacity voltage are divided by 57 volt, and accordingly they have designing the capacitor, and output will be analog, so they need to convert it to the digital. for the digital subscription fulfillment.
And
So only converter is.
yes, and thank you very much for sparing your time, because the technology is quite new and it happens with every new technology. Acceptance takes some time because the people
yes.
are not aware, people are not used to new product. They just want to understand the fundamentals. They need some confidence level, and that confidence level given by your good presentation, your tap test reports, your assurance after sales services that mentioned by Anandji, and clarification of the all doubts raised during
Doubts, yes.
presentation. And if you work on that thing, definitely that product of new technology will be accepted in India across world, and all Indian sectors will get benefit of new products available. With that, thank you everyone for sparing your time, and thank you Ashish Shahji
Yes. Thank
for
you.
your valuable time. Thank you. This series will
Thank
continue.
you, sir, to you, sir. Thank you to you, sir.
Thank you everyone. Thanks a lot.
Yes.
Thank you once again.